Okay, good Friday morning, backyard naturalist friends. My name is Tim. I work at the Urban Ecology Center in Milwaukee, Wisconsin. Thank you so much for joining us, whether you're here in this fun live group, and you have the added advantage that you can interrupt me or interject your questions during the episode, or if you're watching this recorded, you have the added advantage that you can hit the pause button, maybe because your microwave is beeping at you that your coffee is reheated. But either way, I'm humbled and grateful that I get to spend this time with you wherever you are. It's been a little over 2 years since the Backyard Naturalist program started as a result of the pandemic, and it is time. I'm a little surprised it took this long, but it's time. It's time to learn a little bit about this salient backyard critter that objectively, no matter how you look at it, and science even supports that this critter is a pain in our collective butts. Sometimes we'll feature a critter that has a pretty bad rap, and it's my job to be like, you know what? Uh, I know you might hate centipedes or you really don't like yellow jackets, but my job is to have you learn more and maybe respect them a little bit more and understand their awesome natural history. But that's hard to do with the mosquito. So I don't know if I can ask such things of you today. I don't know, unless someone tells me otherwise. I think that it's a pretty collective feeling to hate mosquitoes, even though it goes against my soul as a naturalist. And I'm here to admit and to tell you that I also hate mosquitoes, and I think that's okay. I understand the whole web of life, and if you tug at one string, you affect the others. Um, but with mosquitoes, I think I would be okay if they all disappeared. Biodiversity be damned. Um, from a human perspective, mosquitoes are just these massive vectors of diseases, and some really nasty diseases. My kids and I watched this Netflix series about the world's most dangerous animals, and it was like, kind of March Madness style, where you have 64 entrants and they battle each other to see which is the most dangerous animal. And mosquitoes easily beat out the whole field against other heavyweights like killer bees and hippos and snakes. So I don't know. It's my message for you today. It's my opening message. It's probably going to be my closing message, and it's a theme that will remain strong. That mosquitoes pretty much suck. They make us sick. They make us itch. They ruin what would be an otherwise pleasant experience in our backyards or other green spaces. And so you can probably already sense my excitement to take a deeper look at mosquitoes in episode 39 of season 3 of the Backyard Naturalist, the mosquito host. And before we get started, as always, I would like to just send my deep appreciation to both members of the Urban Ecology Center and to all of the subscribers of the Backyard Naturalist, the Backyard Naturalist Nation. I've made some great new friends in this community, and I really do look forward to our time together. And we've got some fantastic talks coming up in July, including one by our friends at the International Crane Foundation in Baraboo, Wisconsin, the only place in the world where you can find all 15 species of the world's cranes, and one of the favorites of Robin Squire, who spent some time working with them. And we're going to get a visit from some DNR scientists that use spaniels in their work with endangered species of turtles. And then to close out the month of July, we're going to have an extra special mystery guest, just like Harley Davidson had the mystery rock concert with Elton John. I promise you this is going to be better than Elton John. So that's what we're going to wrap up the month of July with for Backyard Naturalist. So stay tuned. And for season 4 of Backyard Naturalist, which starts in September, I hope you all come back. We are also going to add some regular subscriber field trips to some of the local areas around. So there'll be subscribers only field trips to the areas beyond our backyard. And of course, there's also what will become an annual, because we're starting our second appreciation through the potluck, in-person potluck in the fall. But all of that is to say thank you, and we really appreciate your support. And one of my favorite parts of my backyard is the connection to the skies, to the heavens. I love paying attention, watching astronomical events from the elevated playhouse I'm building for my kids, which really right now is just a platform, but it's a great place to just sit and meditate and view the heavens. And there are some important events happening over the next few weeks that I'll quickly highlight. Starting in about a week, China is set to send 2 major laboratory modules to its Tiangong space station, which is already occupied. So there are now 2 functioning human space stations orbiting the Earth. And as the science fiction that we wrote about decades ago are continuing to come to fruition. On July 4th, Earth will be at its aphelion, which means it will be the farthest point we get from the sun, even though here in the Northern Hemisphere, we're at our warmest part of the year because we are tilted towards the sun and therefore bathed more directly in the sun's energy. Then about a week later, on July 12th, we expect a long-awaited treat after years of delays. We're going to finally get our first glimpses at, or mainly first, they sent a couple teasers, but our first major glimpses at the images from the James Webb Space Telescope, because NASA is going to release them to the public. So high resolution color images of places far, far, far beyond our solar system, and really looking forward to that. If you're an early riser, you can still get a glimpse of all 5 of the planets that are visible to the naked eye, all lined up neatly in a row. So Mercury through Saturn. But because we can't see the Earth from the Earth, the moon has conveniently slid into the place where the Earth would be. So you have Mercury, then Venus, then the moon, then Mars, Jupiter, and Saturn, all lined up in a row. And those are the visible components of our our sky. And because there are 7 visible objects that go from that cross our skies, astronomers many years ago named the 7 days of the week after each of those objects. So also a quick reminder that if you missed the strawberry supermoon a little while back, the next full moon on July 13th is also going to be a supermoon. This one will be the buck moon. And then the August full moon will be the sturgeon moon. And those are 3 supermoons in a row, and the last supermoons of the year, meaning the moon is as closest as it will be to the Earth. So, okay, can't dance around the topic anymore. Just like a good root canal, let's sit down and face the realities that are the stories of the mosquito. The folks at Stuff You Should Know called their mosquito episode, which I got a lot of my stuff from, The Mosquitoes, is essentially just called it the worst. And if I don't know, if you're starting to feel a little sorry for all this negativity I'm putting at mosquitoes, I would say don't. They really are the worst. But mosquitoes are on our planet and they visit our backyards. And as such, they have a place in the tree of life. They're actually a type of fly in the order Diptera or Diptera, meaning 2 wings. Mosquitoes are in the order Culicoideae, which places it with several families of midges, including the meniscus midge on the upper left, so named because their larval stage is just under this tiny film of water. And if you ever poured liquids into a graduated cylinder, you know about the meniscus or I don't know, coffee maker, anything. That's what it's named after. And then there's the frog biting midges that are named for obvious reasons, as this poor frog on the upper right can attest to, as the midges in this case are getting a really nice blood meal. And then there are the phantom midges, which are major predators, like dragonflies are major predators in their larval stage in particular. They're all related to mosquitoes. Mosquitoes belong to the family Culicidae, I think, from the Latin culex, which means gnat. And then the word mosquito comes from Spanish / Portuguese, meaning little fly or little gnat. In Spanish, a mosca is fly, And so mosquito is the diminutive of little fly. And the first mention of mosquito in Western literature comes from the year 1583 in the New World. So the word mosquito is very old, and mosquitoes themselves are also very old. Uh, in fact, the oldest fossilized blood a la Jurassic Park came from a mosquito fossilized, not in amber, but in granite that was 46 million years old. So it was fossilized with a tummy full of blood, and the mosquito and its blood meal were both well preserved as fossils. And that leads us to the imagination of what blood is in that. We have no idea. It was 46 million years ago. And unfortunately for the Jurassic Park enthusiasts, 46 million year old blood is not old enough to contain dinosaur DNA. And DNA in general just will not last that long anyway, even if preserved. But the blood could have been from a number of really cool species that were around in the Middle Eocene when this particular mosquito was fossilized. So it's really up to our imagination as to what it bit. And if we look at the basic mosquito body plan, it's like any good insect, they have 3 body parts: the head, thorax, and the abdomen, 6 legs, and because it's a fly, 2 wings. The head contains a lot of extremely fine-tuned sensors. And that's what it uses to find you, and it's going to find you when you're walking through the forest. And if it's a female mosquito, it has that proboscis that it uses to tap into your blood supply. Males do not bite you, and so they do not have a proboscis. And like a fly, they have those really cool compound eyes, and or as a fly, I should say, not like a fly because it is a fly. They have those compound eyes and a pair of antennae. The thorax is pretty small and bulky in between the head and the abdomen, and that's where there's the compound heart, and the thorax also serves as the anchor to the 6 wings and the legs. And then there's that beautiful abdomen that houses the digestive system and is a great storage space for the blood meal that it needs to lay its clutch of eggs. There are over 3,600 described species of mosquito, and there's like hundreds of new species being described each year. And there are 13 genera in the US alone. And when you look at pictures like this, it admittedly, and you take away the whole like disease stuff and the annoyance, mosquitoes are pretty darn cool looking. I mean, there is beauty in there. And even I will admit that. And just like the Milwaukee Bucks have the big 3 of Middleton, Antetokounmpo, and Holiday, mosquitoes have their own version of the big 3, mainly because these are the 3 genera of mosquito that have had the most impact on humans throughout our history. And so and including today. So the genus Aedes, Anopheles, and Culex. So the Aedes mosquitoes they're called the floodwater mosquitoes because they carry out their life cycle in mostly stagnant standing water. Originally, this group was mostly confined to tropical and subtropical areas, particularly in the Old World, in Asia and Africa. But as humans spread throughout the world, they also brought this mosquito with them, and now they're found on every continent except Antarctica. And in many places, including the US, they're considered invasive. And one of the major factors that allowed them to spread so quickly was the used tire trade. So if you think back to the 80s, those of us that are old enough to think back to the 80s, that was a thing I remember hearing about, particularly if you had a tire swing. I don't know many tire swings around anymore, tire swing, or just even tires in your backyard. There was, you'd hear about how, you really gotta make sure they don't hold water, because this was the time when these mosquitoes are really spreading. And so you probably helped if you had a tire swing. The name Aedes comes from Greek, and it means odious or unpleasant. That's a theme in mosquito naming. and this group is well known for carrying and transmitting some of the most popular diseases like yellow fever and dengue fever and Zika. But I also think this group has some of the coolest looking mosquitoes. Just the patterns, the body patterns. This is the yellow fever mosquito. This is the Asian tiger mosquito. And it, even though the yellow fever mosquito is named that, the tiger mosquito can also carry yellow fever and dengue and Zika and those other fun, I'm not making light of it, these other impactful diseases. And it's beautiful. So if you can ignore that other part, I think it is pretty cool. The next member of the big three is the genus Anopheles, and that derives from Greek, meaning useless. So you have unpleasant, and then you have useless, and reflecting this deep-rooted disdain for this group of animals in human history. This is likely the most deadly genus of mosquitoes, mainly because they are the only known carrier of the parasite that causes human malaria. There's malaria in other animals, but human malaria comes through this genus. And then the final member is the genus Culex. This is your most common backyard mosquito. So if you're out in your backyard enjoying it and you see, or even worse, you hear the buzzing, the mosquito, they're poor flyers. This is the genus you're probably coming across most often. And as weak flyers, it's easy for them to kind of blow away, or if it rains or something, but conditions are right often enough for them to come and say hello to you. This group prefers to feed on birds, but they're happy to feed on you. They carry avian malaria, but not human malaria. And really more annoying than dangerous around these parts. So those are the big three, and then that leads us to the questions. First, why are mosquitoes so good at finding us? Second, why do they want to find us? And then third, why are mosquito bites just so annoying? So we'll go back to that mosquito head. The thing that makes mosquitoes so good at finding us or other animals is they have multiple very fine-tuned, very accurate sensors, and they rely on several different methods to find us. So just like a bird that migrates is going to look at the stars and the sun and landmarks, the mosquito has many, many different ways to find us. So even if you tackle one, you got the other. So probably the most important are the chemical sensors. So we as humans emit several chemicals and volatile compounds, and several of those will attract mosquitoes. So if we start with the most basic is carbon dioxide, mosquitoes probably couldn't have picked a better compound to focus on to bring them to humans, because in order to live, and other animals, in order to live, we have to breathe. And when we breathe, we emit carbon dioxide. So that's great because mosquitoes use carbon dioxide to find us. The chemical receptors in a mosquito enable them to detect a single carbon dioxide molecule from 100 feet away with directly to a neuron receptor that binds with the carbon dioxide. And so instantly alerting the mosquito that something's up, somebody's there, somebody's ready to be investigated. So carbon dioxide alerts them. If for whatever reason the carbon dioxide isn't doing the thing, mosquitoes are also very sensitive to lactic acid. So that's another compound your body produces to help stay alive. And lactic acid particularly is produced when you're doing exercise, and your oxygen content in your body starts to go down. Lactic acid is then produced through sweat. So if you're sweating, you're increasing the likelihood that mosquitoes will find you through lactic acid. And then a third major attractant of mosquitoes is a volatile compound called nonanol, or also nonanaldehyde. And this is something your body produces naturally again, but it's also found in perfumes and natural oils. And particularly now when mixed with carbon dioxide, it makes you a particularly easy target for mosquitoes. They can just be laser focused on you. So it's something to think about. Anytime you rub something on your skin, whether it's a perfume or deodorant or something, there is a chance that you are making yourself more attractive to mosquitoes. And between these three things, we pretty much have no chance not to be found by mosquitoes. But that's not it. There's more that makes that tilts the playing field heavily towards towards the mosquito. They also can see well. Not all insects can see well. Mosquitoes can. And if they can't see you, or if they can't smell you, then they can still often see you. So if you're trying to lower your chances of being found by a mosquito, you may have heard this or read this before, that you should wear muted colors. If you wear muted colors, that kind of helps you camouflage with your surroundings. Just like if you're trying to avoid a T-Rex attack, the less you move, the less likely the mosquito will see you. So if you're in a forest with lots of greens and browns around you, you're going to want to wear these muted greens and browns and tans. That'll kind of help you hide from the mosquitoes. But if you're wearing white or black or any really bright colors, you instantly become a target, especially if you're moving around a lot, because you're providing contrast to the background. And then between the contrast and the movement, the mosquito is going to hone in on that pretty quickly. So, if you're saying to yourself, okay, all I have to do now is not breathe, not sweat, not put on perfume, stand very still, and the mosquitoes won't find me. But as if they needed another advantage, they also have sensitive sensors that can detect infrared, meaning they can actually see the heat that your body produces. So pretty much if you're alive, a mosquito has many ways to find you. But there are some things you can control, and avoiding perfumes, wearing this muted clothing, and the other things. So they're very good at finding us. And then the question is why? Why do they want to annoy us so badly? And the answer here is that our bodies are loaded with something that female mosquitoes need to pass on their genes to future generations, and that is blood. And again, it's only the female mosquitoes that need the blood. Male mosquitoes don't have the proboscis. They pretty much just hang out eating plant nectar. But female mosquitoes are hematophagic, so they ingest blood, and they only need your blood when they're about to produce a brood of eggs. They don't need it if they're not producing eggs. But it's the protein rich, the lipid rich blood that helps them to produce their brood of future mosquitoes, the baby mosquitoes. So if you see a mosquito around, you know that it's female, and you know that it's about to lay some eggs if it's trying to bite you. And this is where we'll take our first and only video break that looks at the fascinating process of how a mosquito accesses your blood. If you're squirmy, you might want to look away from the screen, but I was pretty glued to the screen when I first saw this because it is really cool. And I mean, to me, like a mosquito bite was just like you go to the doctor, they put the hypodermic needle in, but it's way more complex than I certainly knew. So we'll have a look-see.
Tim, I think you may need to share your sound.
Oh, thank you. I probably forgot to do that. I did forget to do that. You don't really want to hear the mosquitoes anyway, do you? I'm going to stop share and then start sharing again. There we go. Okay. Thanks for letting me know. Let's see if this works.
We can hear it.
Good.
This is the deadliest animal in the world. Mosquitoes kill hundreds of thousands of people each year. The most vulnerable people, children, pregnant women. No other bite kills more humans or makes more of us sick.
They're the big three
So
right
what
there.
makes a mosquito's bite so effective? For starters, they're motivated. Only females bite us. They need blood to make eggs. And a pool of water for their babies to hatch in. Even a piece of trash can hold enough. At first glance, it looks simple, this mosquito digging her proboscis into us. But the tools she's using here are sophisticated. First, a protective sheath retracts. See it bending back? If you look at a mosquito's head under a microscope, you can see what that sheath protects. And inside there are 6 needles. 2 of them have tiny teeth. She uses those to saw through the skin. They're so sharp, you can barely feel her pushing. These other 2 needles hold the tissues apart while she works. From under the skin, you can see her probing, looking for a blood vessel. Receptors on the tip of one of her other needles pick up on chemicals that our blood vessels exude naturally and guide her to it. Then she uses this same needle like a straw. As her gut fills up, she separates water from the blood and squeezes it out. See that drop? That frees up space to stuff herself with more nutritious red blood cells. With another needle, she spits chemicals into us. They get our blood flowing more easily and give us itchy welts afterwards. And sometimes, before she pries herself away, she leaves a parting gift in her saliva. A virus or a parasite that can sicken or kill us. There's nothing in it for her. The viruses and parasites are just hitching a ride. But this is what makes mortal enemies out of us and mosquitoes. They take our blood. Sometimes we take theirs. But often not soon enough. Good, you're still there. These are the larvae of Culex pipiens, aka the common house mosquito here in California. Gross, right? Well, you can avoid them by emptying your rain gutters, pet water dishes too. While you're at it, subscribe. We have so many more science videos coming your way. See you next time.
All right, so the female mosquito lands on you. It injects that complex hypodermic needle into you to access your blood, and then injects that anticoagulant to keep the blood flowing. And then when she's full and she flies away, but then after she flies away, there's still that reserve of anticoagulant in there, and then your body recognizes it as not self, not something you produced, so it sends the white blood cells, they congregate at the site, and then they start breaking down that anticoagulant, and that's the process that produces that puffy area of inflammation, which is called the wheal, which then becomes the bane of your existence for quite a while, because all you want to do is scratch that wheal over and over and over and over again. So while you're scratching, if you want to impress your friends, you can say how annoying these wheals are. There are plenty of over-the-counter anti-itch remedies for you to choose from. And there are probably even more home remedies, from toothpaste to honey to banana peel to vapor rub to ice to aloe vera. In the Vargo household, we used vinegar. That was our anti-itch of choice. Little vinegar and a washcloth rubbed onto the bite. I have no idea if it worked. But to this day, when I smell vinegar, I still think of my childhood summers. But here's something surprising I learned on the Stuff You Should Know podcast. And another thing that I did as a kid is I would take, if there was a particularly itchy mosquito bite, I would take my fingernail and just drive it straight into that bite as deep as I could handle, kind of mix of pleasure and pain. And then turn my nail 90 degrees and make an X, just like you see here. I don't know if I learned that from someone else. I don't know if that's just kind of a natural thing to do. I just think people do it, because it seemed to work and it felt good. But according to the American Allergy Institute, this method may be just as, if not more effective than those over-the-counter remedies, because what it does is it disrupts that immune response to the anticoagulant. And then this only lasts, of course, until, that immune response is fired up again, but maybe by then you're a little more distracted with something else. Who knows? So the female mosquito injects you with this anticoagulant. She starts removing your blood, and then she's going to continue that process until she gets the signal from her abdomen that blood storage tank in the abdomen is full, and then she'll fly away to lay eggs. And scientists in a lab, and I don't know, you may think this is cruel or you may think it's sweet vengeance, but when scientists are able to disrupt the signal that tells the mosquito that she's full, then she will continue to draw blood until her body essentially explodes from drinking too much blood. But in real life, the mosquito, when she's finished, she'll fly away and then begin the process of making and laying eggs. Most mosquitoes lay their eggs on the water in essentially a floating raft. So if you see this, you may want to do something about it if it's in your backyard, unless you're really into mosquito conservation. Some species of mosquitoes will lay their eggs on land that has a high probability of flooding, either seasonally or regularly, like wetlands. But most mosquitoes lay their eggs directly on water. The eggs then hatch into these cool aquatic larvae. In the Anopheles, like on the upper left, the larvae live parallel to the water surface, but most of the other larvae are perpendicular, and they have these air tubes kind of extending from their rear ends to the surface. And I remember seeing this in my yard as a kid, and I was fascinated by it. I mean, I probably knew they were mosquito larvae, but it was just really fun to watch them kind of regularly dive down into the water with these like undulating motions. They're called wrigglers. So they'll go down and they'll eat algae and detritus and other kind of microscopic organisms that they can find. And then they come back to the surface to breathe. But I just really enjoyed observing that behavior. And I don't know, today I probably would just dump the water. Sorry, mosquitoes. But there are insects, and like any proper insect, the larvae then will continue to molt and grow into various instars. And then the fourth molt results in mosquito pupae. So this is the mosquito version of the cocoon, or the chrysalis. And so just like a butterfly, that the mosquito larvae encases themselves in this cocoon-like vessel. They stop eating, and then they just go through all the internal changes. They're still at the surface of the water. And then essentially they're forming themselves into the adult form. And in a really beautiful and magical transformation, the adult emerges from the floating pupae with the help of a buildup of air pressure. And it's just like as if they're being born right out of the surface of the water. And if you're wondering what happens to mosquitoes in winter, the adult female will already have mated and already have produced eggs in the fall. And then they just kind of find a place to lay low and make it through the winter. And then in the spring, when it gets warm enough, they're already ready to lay their eggs. But in places like Iceland, it's too cold for even mosquitoes. And other than, I think, a pretty big population of gnats, it is kind of nice in Iceland because there's no mosquitoes. But so I don't know, you can kind of see even mosquitoes have that natural magic and beauty. They're living creatures on our planet. I'll try not to forget that. But again, it's easier to forget that when you go back to the part about the diseases. So they're major vectors of disease. Malaria is an awful disease that still to this day kills about 1 million people a year around the world. which is really sad, especially considering we have the tools to fight this disease. And one of the tools might even make their way to your backyard if you enjoy a bit of gin and tonic. Tonic water is made by dissolving quinine into a carbonated drink, so it makes it a little bitter. And we learned about this, as we did with so many things, from indigenous people of the Americas, Peru, Bolivia, Ecuador, who use the bark from the cinchona trees to treat malaria. And they've been doing that, for hundreds and hundreds of years. The treatment was brought to India by the British Empire, and where at the time malaria was a big problem for soldiers. And so the British, as they do with other things like tea, they mixed sugar into a tonic, into a carbonated water to kind of mask that bitter taste of quinine. And then that was the birth of tonic water that we still drink today, and still has quinine. It's just the amount of quinine is much, much reduced. So British soldiers also got a ration of gin. And so it probably didn't take long to realize that gin and tonic, when mixed together, make a nice refreshing drink. Add a bit of lime, which will help with your scurvy. And then you have this perfect combination that has lived through today, and probably why many tonic waters are still infused with citrus flavors. And tonic water is used in other cocktails like vodka tonic. And there's a newer craze some of you may heard of out of Sweden. Apparently, it's the espresso and tonic, which is growing in popularity. And then final quick fun fact before we go back to mosquitoes is that the quinine in tonic water will also fluoresce under UV light. So if you put your gin and tonic under a black light, or even sometimes if it's in direct sunlight and it's got a dark background, you may see a little bit of a glow from the quinine and the tonic. But at the end of the day, the chemicals in quinine prevent the spread of the malaria parasite in your body, which is a big deal and had a huge effect on the world's historical events. And again, it's not just malaria, it's yellow fever, encephalitis. There was a huge scare in 1999 when, over a very short period of time, 7 people died of a form of encephalitis that we called West Nile virus. And then there's dengue, which uses worms. It can make you blind. So there's just so many bad things. So with all of this danger, we're continuing to try to find tools to prevent mosquitoes from biting us in the first place. And so just like with all those anti-itch products, there's a huge industry of both over-the-counter and home remedies for as mosquito repellents. And then the biggest breakthrough came in 1944, a chemical known as DEET, originally designed for military application in World War II, further developed in Vietnam. It was also tested as a pesticide. And DEET has been shown to be very effective against mosquito bites. And one of the craziest things, though, is that we still don't really understand why the mechanism, but we do know that it works. The leading theory is that it interferes with the CO2 and the non-analdehyde receptors in the mosquito. But we still don't have a really good, at least as far as I know, a really good idea of the mechanism behind DEET and why it's so effective. And there are just also some major health and environmental concerns with DEET that keeps many people, including myself, from using it. It is known as a plasticizer, meaning it essentially can melt plastic. And just like with sunscreen, I'm hesitant to use certain sunscreens and insect repellents, mainly because I'm hesitant to put things on my skin that will be absorbed into my bloodstream. And so the non-metallic sunscreens and the DEET will make your way into your blood, but the concentration should be small enough that it's broken down by your liver. But in higher concentrations, there are many health risks, including seizures, Kids are particularly vulnerable, not only because, you know, they're smaller, but they like to put things in their mouth. And if you ingest DEET, the concentration just becomes hundreds of times greater. And that can really cause problems, even if it's just like licking your hand or your arm. So this is a really tough one. You know, do you risk the dangers of DEET? Do you trust the companies that are profiting off of it that tell you that it's safe? Or and that's not just DEET. That's, you know, some of the newer chemicals that, you know, DEET's got a pretty bad rap. So they're newer chemicals that, you know, maybe just as bad as DEET, but they're alternatives. Or do you risk the dangers of the very real dangers of what a mosquito might pass along to you? So, you know, there are those other things, you know, wearing longer clothing, mosquito nets, tents around, you know, beds, rooms, screens, that kind of thing. There's a lot you can do. And, you know, we're still in some danger here. We're not in an area of the world that has a ton of risks. And as mentioned, our backyard mosquitoes are relatively harmless, but there is still some risk. But I choose the latter. I choose not to use DEET, but I do allow myself to dabble in the many alternatives that are out there. Lemon eucalyptus, apparently soybean oil can be quite effective. Citronella, when processed, a citronella plant is not gonna help, but if you have that processed, so that the compound ethyl pyrorate comes out, that apparently will mask some of the compounds in the volatile gases that you produce and make it harder for the mosquitoes to find you. People also use mosquito traps by producing compounds like carbon dioxide, and essentially you need the traps to become more attractive than you. And they can be effective, but they're pretty resource intense and seems like a pretty big thing to do. Don't use bug zappers. I think thankfully they're pretty out of style, but essentially you're not helping to get mosquitoes. You're just killing all of the insects, and many of them are the beneficial ones that we want around, and you're really only killing mosquitoes if they happen to fly by. So don't use bug zappers. In theory, people have marketed that sound can affect mosquitoes, either interfering with the mosquito's natural processes. Some say that certain sounds will mimic dragonfly wings, and dragonflies are excellent predators on mosquitoes. But there was a radio station in Brazil that advertised that it was going to broadcast a low frequency sound underneath its music that we would not hear, that humans can't hear, that would repel mosquitoes. So all you had to do to stay safe from mosquitoes was to turn on their radio station and stay near your radio. At the end of the day, it was a marketing gimmick, a clever one. And you know, it's a market that people want to. I mean, it's easy to tap into this market because we don't like mosquitoes. So there are a lot of other devices that are advertised to drive away mosquitoes with sound waves. But as far as I know, none of these products are effective at all. And you're just wasting your money, I think. And then I don't know, this is maybe my second PSA after the bug zappers after DEET 2. There are companies that put mosquito repelling chemicals like permethrin directly into the fabric of clothes, and that appears to be safe. So you'll see a lot of these mosquito repelling shirts and pants. They may work. I personally am a little terrified because permethrin on your skin can be deadly. It's a neurotoxin. So, you know, whether it's safe if it's in the clothes, it might be, but you're also putting, you know, those clothes in a washer, and, you know, the chemicals are moving around. So I don't know. The jury's still out there. It's probably okay, but it's not something I'm going to buy anytime soon. So that is the scoop on mosquitoes. they're annoying. They're the most deadly animal in the world. Many people, including myself and the podcast hosts, and actually a lot of scientists have looked into the question, what would happen if the mosquitoes just went away? They're gone. They just disappeared. And the ecologist in me says it would be terrible, right? Because they're the food item for a lot of animals, including fish, bats, dragonflies, birds. But there are also a lot of other insects out there, and you just have to wonder if they would make do and just switch to something else. There's a fish called the mosquito fish. And as soon as it was given the name the mosquito fish, it started to spread all around the world as mosquito control. And now, of course, is an invasive pest. But even the mosquito fish is a generalist predator. So if there are a lot of mosquitoes around, that's just going to make up the bulk of their diet by chance. But they'll also do just as fine without mosquitoes. And so, it is, I think, a valid question. Would the world be a better place without mosquitoes? Maybe, but then I think of like the rest of the animal world and how they would answer that question, and they'd probably say like, "Are you kidding me? We need mosquitoes to keep the human population in check," and that would be a pretty decent argument as well. So we will finish with one of, I don't know, the most beautiful mosquitoes out there, and even though I talked big at the beginning, I guess I do respect them a little bit more after learning more about them. I just still don't like them. So thank you for joining us again today. I will stop sharing my screen. And